All right. This is a quick practice on combining resistors down. So let's take a look real quick. So we got to find our equivalent, and our equivalent just translates to one resistor. So if we look at these two here, that's going to be our first parallel value. So we can write off to the side here. Our parallel 1 is, pardon me, going to be equal to 12 times 24 over 12 plus 24. Will give us 8. And then real quick, if you're joining us, could you go on mute until the end when we ask if anyone has any questions? All right. So that's our first parallel question. So if we come over here and sketch it out. We'll see that this will now be R parallel 1 is equal to 8 ohms. Then we have R4 is equal to 3. And R5 is equal to 4 ohms. Then real quick, we'll write this up here for us. Just how we got the R parallel equation. Okay. So now that we have this, we see that we have these three all on the same wire. So we're going to say this is series 1. So series 1, if we do R series 1, that will be R4 plus R parallel 1 plus R5, which will give us 3 plus 8 plus 4, which should give us 15. Okay. So I find it early on in the semester especially, it's helpful to redraw the circuit every time you make a change to it, just so you can keep track of where you're at. We have a question in the chat. If there was a node between R4 and RP1, would it still be in series? So we're saying that you can just say yes or no. If you're saying something like that. Okay. So kind of what, yeah. So what we're saying is here is that say if there was a node right here, so say there was another wire, right? So this system wouldn't be in series because we have that addition of this wire here. And what that does is that makes the current now choose two different paths, and it doesn't make it series anymore. Okay. But if it was on the same wire, yeah. So so if the question is if it's on the same wire, so if there's a big node right here, just say yes or no. This is what you're trying to. Yeah, so a node, that's totally fine. The node is on the same wire. So that current is just going to come through here, travel through here, and go this way. Okay, and that's perfectly fine. A node is just a point on a wire, but a node at a junction changes it. All right. All right. Okay. So then now we see that these three are in series, so we'll go and add them real quick. And if we were to drop these here, this will be our series 1. This will be R3, and we've got those two here. Okay, so then now we see that these two are in parallel, so I'll call that parallel 2. And luckily, there's only 2, so I can say R parallel 2 is equal to R3 times RS1 for R3 plus RS1. And this would just be equal to 30 times 15 over 30 plus 15. Times 15. And this should give us 10. And finally, if we redraw it one more time, this will be R parallel 2. This is R1, and what number is that? R2. And this is R2. We'll see that these three are in series, so I'll call this series 2. And we'll say R series 2 will be equal to R1 plus R parallel 2 plus R2. And I forget what those values were, 3 and 7. So 3 plus 10 plus 7. So R series, that's a 2. R series 2 will be equal to 20. And I lied to you, we gotta draw it one more time. And this will be R series 2. And there's only one resistor left. So our R equivalent is equal to R series 2, which is equal to 20 ohms. Okay, and does anyone have any questions about this one? You can unmute yourself or you can drop something in the chat. All right, seeing none. So we can go and move on to the next one.